So we're on page 9 now of the video, and I'm going to be walking you guys through examples 1 and 2, and we're going to then check, and then I'm actually going to teach you guys how to put everything we've been doing together with some examples on pages 9, or at the bottom of page 9 I should say, and then on over to page 10. Alright, so this is a video for pages 9 and 10, and we're going to get started here with the first one. So we've got 12x minus 48 equals 60 minus 15x. First thing we're noticing is that we've got 1, 2 terms, and we've got 1, 2 terms. So we don't need to simplify on either side because we've got 2 terms. And now we need to focus on the coefficients. So we have a 12 with our x and a negative 15 with the x. Y'all, which number is smaller, 12 or negative 15? Alright, so negative 15 is smaller, and that's why we're going to start right here, and we're going to choose to do the opposite, and now we're going to add 15x to both sides. When we add 15x, that cancels out over here, and on this side, 12x's plus 15x's is 27x's. Now we have a very familiar two-step equation left to solve. Our constant is a negative 48, so we're going to add 48 to both sides to cancel it out here. I bring down the 27x. 60 plus 48 is 108. Now I'm going to divide on both sides by this 27, so it cancels out here, and 108 divided by 27 is 4. So now we've got that x equals 4, and what we're going to do is we're just going to plug it in on this side and over here on this side, and we can pretty much just simplify using PEMDAS. We don't know what number to expect when we check, but we just know that whatever we get on one side should equal the other side, and that's how we know we're right. So if I plug in a 4 over here, 12 times 4 is 48, minus 48 would be 0. Now on this side, if I plug in a 4, 15 times 4 is 60, and 60 minus 60 would be 0. So since I got the same number on both sides, I know that we are right. Alright, now let's take a look at number 2. So once again, 2 terms, so we don't need to simplify by combining like terms or distributing. Now we just need to focus on the 18 and the 6. Between 18 and 6, which one is a smaller coefficient? 6. So, since it's a positive 6y, we're going to subtract 6y on both sides so that it cancels out over here, and I bring down my negative 12. Over here, 18y minus 6y is 12y, and then I bring down the 24. Once again, we're left with a very familiar two-step equation. 12y plus 24 equals negative 12. So now to solve, we've identified our constant is positive 24, and we subtract on both sides. This is the same sign, add and keep, so we get negative 36 over here. I bring down the 12y, and at this point I'm ready to divide on both sides by the coefficient of 12. And I want to point out that in both of these situations we got a positive coefficient, meaning we would not have to worry about flipping the symbol if these were inequalities. The goal of going after the smaller coefficient first is to avoid a negative so that in the inequalities unit you would not need to flip the symbol. Alright, now we're just going to plug in the negative 3 here, and we're going to plug it in over here. And when we simplify here, we get a negative 54 when we multiply, plus 24, it gets closer to 0, we're at negative 30. On this side, a 6 times a negative 3 is a negative 18. And then when we subtract 12 from that, we're going to get further away from 0, and we're going to end up at negative 30. So since we got a negative 30 on both sides, we know we're good to go. So this video so far, we've just walked through a couple of practice examples, and you're just starting to get the hang of go after the smaller coefficient first, and then do the opposite with that on both sides, and then you know how to solve the rest with a two-step equation. So now we're going to kick it up a notch a little bit, and in number 3, we're going to kind of put everything together where you might need to combine like terms or distribute first to simplify, and then you know how to solve the equation with the variable on both sides. So let's take a look at number 3. For number 3, the first thing you're going to notice is that you've got 1, 2, 3 terms here. So we need to simplify right there and turn the negative 5r plus 12r into a 7r. Now I've got the minus 3, and then on the other side I'm just keeping the equals 16r minus 21. So now we're at the point where we have a variable on both sides. We have 7r over here and 16r over here. So as coefficients, which one's smaller, 7 or 16? 7 is smaller. Since it's a positive 7r, we're going to do the opposite and subtract on both sides so it cancels out. Notice I just bring down the negative 3 in my work. And on this side, 16r minus 7r is 9r. Over here, we just bring down the negative 21. And this is a very familiar two-step equation. Negative 21 is your constant, so you're going to add 21 on both sides. Negative 3 plus 21 is 18. And now you've got 18 equals 9r. And we're going to divide on both sides by the 9 for it to cancel out. And we'd get that r is 2. Now this is the part in the video where I need to be very, very clear about something. That right here, you're combining like terms, and you just do negative 5 plus 12, and we get a positive 7. When you're solving is when you do the opposite, and since we have a positive 7r over here, that's when we subtract on both sides. So just be careful when combining like terms. You're simplifying, you do negative 5 plus 12, and we get a 7r. Now when you drop the line and solve is when you want to do the opposite, and we've got a positive 7r, so that's why we subtract 7r on both sides. Up top, I'm just going to refer back to the top example real quick. I want to go back now and point out that for this first example, we only had 2 terms here, and we only had 2 terms here, so we did not need to combine like terms at all. And because negative 15 was smaller than 12, when we solve, now is when we do the opposite. So now that I'm ready to drop my line and solve, that's why I do a plus 15x on both sides, okay? So it's not supposed to be 12x minus 15x to get a negative 3x. That would be combining like terms, and you'd only do that if they were on the same side. All right, so I'm back down here to number 3. We simplified first, we just combined like terms, and then we had a variable on both sides. So we dropped the line and started with the smaller coefficient. Now that we've got r is 2, I'm going to check by plugging it into the original equation everywhere I see an r. So I saw an r here, here, and on the other side. So I've plugged it in, and I'm going to multiply now. I've got a negative 5 times 2 is negative 10. 12 times the 2 would be a 24. And then, of course, I have the minus 3. So negative 10 plus 24 is a positive 14. And now 14 minus the 3 puts me at 11 on this side. Now on the other side, 16 times 2 is 32. I don't know why I have a 3 and a 48 there, but 16 times 2 would be 32. And 32 minus the 21 is 11. So we get 11 on both sides. I have no idea why the original time I wrote 16 times 3 is 48. That is definitely wrong. And 48 minus 21 is not even 11. So I'm like super wrong here. It definitely should be a 2 that we plug in. 16 times 2 is 32. And 32 minus the 21 is definitely an 11. And we're good to go now because we got 11 on both sides. So we know that r equals 2 is the correct answer. Now I'm going to have you guys flip over because this video does continue on for page 10. And I'm going to now just explain number 4 and walk you through this container problem. All right. Now number 4, let me point out to you here that on this side, I don't just have my 2 terms. So on this side, I'm going to need to distribute first, then combine like terms to get it to 2 terms. So you're going to see here, I've got a negative 3 times 2. That's where I got my negative 6. And negative 3 times a negative 1u. Let me write that out just up above so you can see it. I'm saying a negative 3 times a negative 1 with that u. Okay? So this negative times negative is where I got my positive 3u. Now I'm just bringing the negative 6u down. And we can combine like terms here. These 6 negative u's plus 3u's is a negative 3u. And now on this side of the equation, you can see I've got my 2 terms. On this side, I just continued to write down the negative 4u plus 14, negative 4u plus 14. Now on this side, I only have 2 terms. On this side, I have 2 terms. So now we're ready to drop our line and solve. Now between a negative 3, y'all, and a negative 4, if you have a negative 3 and a negative 4, which number is smaller? Negative 4 is smaller, so that's why I'm on this side right now. And since it's a negative 4u, I'm going to do the opposite now and add 4u to both sides. That cancels out my u's over here. And on this side, a negative 3 plus 4 just becomes a positive 1u. You do not need to write the 1. And you have your minus 6, and you bring down the 14. So now we have u minus 6 equals 14. We just add the 6 for this to cancel out. And we already have u by itself, and u would equal 20. So for this problem, what we had to do was we distributed first, then combined like terms to simplify this expression. Now that this expression was simplified, we have a variable still on both sides, and we're ready to drop the line and solve. I went after the smaller coefficient first, negative 4, and now I'm doing the opposite. I've got plus 4u on both sides. That canceled out over here. Negative 3 plus 4 is a positive 1u, and again we get u is 20. Now let's talk about the check step, okay? So I've got the 20 that I've plugged in for u here, and I've got the 20 that I've plugged in for u here. So 6 times u, or negative 6 times u, is a negative 120. Now I've got minus 3 times whatever happens in here. So 2 minus 20 is a negative 18. Now 3 times that negative 18, this negative 3 times this negative 18 is my positive 54. So negative 120 plus 54. On this side we get a negative 66. If you want to use your calculator along the way to check with me, I highly recommend that. Now let's take a look at the other side. So negative 4 times 20 plus 14. So negative 4 times 20 plus 14. So this is a negative 80. And when you add 14 to that, you're going to get closer to 0, and it's also a negative 66. And since we get a negative 66 on both sides, we know that plugging in a 20 was the right thing to do. All right. Now for this part of the video, I'm hoping that not everybody who's watching the video is just kind of looking at the numbers and copying and then muting me. I hope you're actually listening along the way. And now I'm going to kind of go through this word problem pretty in depth. We've got container A and container B. So here's container A and here's container B. And there's holes on the side. So these two containers are leaking. Container A has 800 milliliters of water, and it's leaking at a rate of 6 milliliters per minute. So in this container, it has 800 milliliters of water, and it's leaking at a rate of 6 per minute. So that's where I came up with this equation, that in container A, it starts out with 800, but it is losing 6 milliliters per minute. Now over here for container B. Container B has 1,000 milliliters in it, and it is leaking at 10 milliliters per minute. So if I just kind of sketch real quick, let's let that be container A, and let's let this be container B. Container A starts out with 800 milliliters. Container B starts out with more in it. It starts out with 1,000 milliliters. Now this one starts out with more, but it's draining faster. It's leaking faster because it's losing 10 milliliters per minute. This one's leaking and losing only 6 milliliters per minute. So this one starts out with more. However, it is also leaking faster. Okay? So for the first question, I want to know how many minutes will it take for these two containers to actually have the same amount of water in them. I want these two water levels to be the same. So what we're going to do is we're going to take container A and we're going to set it equal to container B. And when we set it equal to each other, this is us seeing for the first time an equation where you'd actually have the variable on both sides with a negative coefficient. So here, this is the equation that we're about to solve, and I want to ask, which is a smaller coefficient, negative 6 or negative 10? Negative 10 is smaller than negative 6. It's further away from 0. So the first thing I'm going to do then is add 10m to both sides for it to cancel out over here. And on this side, negative 6m plus 10m is positive 4m. I just bring down the 800 and the 1,000, and now I'm ready to solve. So I'm going to subtract the 800 from both sides for it to cancel out. And we're left with 4m equals 200. Now divide by your 4 to get m, and m is 50. What that means, y'all, is that if M is 50, these two things equal each other. So after 50 minutes, both of these containers are going to have the same amount of water in them. So after 50 minutes, I can now say, if I redraw these containers, if it was 50 minutes in of leaking, they would both be at the same level, okay? Now, a follow-up question there is, when they are level, how much water is actually in them? And that's actually what happens when you plug in the 50 on both sides. When you plug in the 50 on both sides, we get 500 on both sides. That means that after 50 minutes, both of these will have 500 milliliters of water. If this started out with 800 and decreases 6 milliliters per minute, after 50 minutes, it would have 500 milliliters of water left in it. Now this one started out a little higher, but it's also leaking faster. And what we're saying is that if it started out at 1,000 and drained at 10 milliliters per minute, after 50 minutes, this side would also have 500 milliliters of water, okay? So after 50 minutes, they'll both have 500 milliliters of water. Now the next question I'm asking is, which container will empty first? So the idea is that this is container A. And we want to know when container A is empty, so we're going to set it equal to 0. Same thing over here for container B. If this is the water in container B and we want to know when it's empty, we're going to set it equal to 0, and then we'll know for M how long it took for this thing to be empty. So that's the next set of equations you're about to see. Over here, this is container A. It's draining at 6 milliliters per minute, and it started out with 800. So when we subtract the 800 from both sides, we get a negative 800. Now divide it by the negative 6, and we can see that container A will be empty after a little over 133 minutes, okay? Friendly reminder that 120 minutes would be 2 hours. So this is going to take more than 2 hours, okay? Now over here for container B, when we set it equal to 0, when we subtract the 1,000, we get a negative 1,000, and then divide by your negative 10, and we see over here that container B would be empty after only 100 minutes. That would be less than 2 hours. So this one, because it's draining faster, we can see here that it would only take 100 minutes for this one to empty. Yes, it started out with more, but it's draining faster, so it will empty first. And that concludes the video for pages 9 and 10. Thank you.